Okay, so Laplace transform of integrals. Okay, so we have the following result here. So let f of s, okay, denote the transform of f of t, where f of t is, or we can say which is a piecewise continuous function. Continuous for t is greater than or equal to 0. And f of t satisfies the existence condition. So simply f of t, the absolute value of t can be upper bounded by m e to the power kt for some constants m and k. Then for s is greater than 0, s is greater than k, and t is greater than 0, what do we have is the following result, okay? We have the Laplace transform of the integral from 0 to t for f of tau d tau is equal to f of s divided by s, okay? Or simply the inverse Laplace transform, okay? This is the other interpretation of this one, of f of s divided by s, okay, is given by the integral from 0 to t f of tau d tau, okay? So here I'm using f of tau d tau just to distinguish between t and tau, okay? So here this should be a function of time, independent variable t, okay, time, function of time. So when you integrate f of tau d tau from 0 to t, what you get is another function of t, okay, of the independent variable t. Now, how do you prove this result? Okay, so here we have proof. So how do we prove that the Laplace transform of the integral from 0 to t f of tau d tau is equal to f of s divided by s? What do you think? How do we start? Any idea?
دكتور ممكن الاشتقاق الضمني لما نشتق بطبعا اف اف اس برايم دي نفسها اف اس ونشتق من جوا بيطلع اس برا فاس اس بتروح بتضل عندنا اف اف سي اللي هي اصلا ضربناها في اس في اللابلاس الاصلي.
You lost me. أنا مش فاهم. إيش دخل اشتقاق ضمني؟ أنا مش فاهم.
قصدي لما تشتق الدال نفسها فهمت تشتق اللي جوا اللي هي الاس بدلالتها والدال نفسها.
Okay. Any idea? مين بحكي لي؟ So, جماعة, we should think of this one. Sorry. Okay, we should think of this one as g of t. What's inside here? So here, we can say that let g of t is equal to the integral from 0 to t f of tau d tau. Okay? So this is g of t. Now, let me ask you this. Now, taking the derivative of both sides with respect to t, what do you have? Now, d by dt, okay, I'm differentiating with respect to t, okay, I'm taking the derivative with respect to t. So here we have g of t is equal to d by dt, integral from 0 to t, f of tau d tau, okay? Now the left-hand side should be g prime of t, right? What about the right-hand side? What do you think? What is the derivative of the integral from 0 to t f of tau d tau?
0.
0? Why is it 0?
عشان ما في عندنا t من tau.
No, this is a function of t. So this one, the fundamental theorem of calculus. يا جماعة, fundamental theorem of calculus, it tells you that the derivative of the integral from 0 or minus infinity to t f of tau d tau is nothing but f of t. So يعني basically the derivative will cancel out the integral. Do you agree with me يا جماعة ولا لا؟ فاهمين ولا مش فاهمين؟ فرح
تمام.
فرح لو كانت ألفا هون this is fine. Okay, بس as long as it's t. So ما احنا صرنا ساعة بنحكي إنه this one is a function of t. So when you take the derivative with respect to t, you should get the you should get a function of t, and that function, so the derivative will cancel out with the ish with the integral basically. Okay, so here we have t, not alpha. Okay, so in general we might have anything, but specifically we are talking about t. So this one is a function of t. The derivative should be a function of t. So the derivative of the integral from 0 to t is what's inside, is the integrand, okay, being evaluated at t. Okay, so from here we have g prime of t is equal to f of t, right? So now if we take the Laplace transform on both sides, so what do we have is s g of s minus g of 0 is equal to f of s. Okay, but let me ask you this, what is g of 0 in this case? From here, g of 0 is the integral, g of t is the integral from 0 to t f of tau d tau. Now g of 0 is the integral from 0 to 0 f of tau d tau. And what is this? What is the integral from 0 to 0?
0.
0. Why is it 0?
ما فيش مساحة في الشيء.
Excellent. The area is 0, okay? Since the area is 0. So now having g of 0 is equal to 0, so what do we have finally? So s g of s is equal to f of s, okay? Or simply g of s, okay, is equal to f of s divided by s. So this implies that the Laplace transform of g of t is equal to the Laplace transform by uniqueness of the Laplace transform. Okay, this is very important. So since the Laplace transform is unique, okay, or basically can be uniquely determined. So if g of t is equal to f prime of t, then the Laplace transform of g of t must be equal to the Laplace transform of f of the integral. Okay, if g of t is equal to the integral from 0 to t of tau. So here we have the Laplace of integral from 0 to t f of tau d tau, and this one should be equal to f of s divided by s. Okay, so that's what we have. So we proved the results above. Okay, in this case, all what you have to do is to find the Laplace transform of f of t. Okay, and then if you have an integral formula from 0 to t, then you have to divide by s. If you are given some function g of s in here, so try to think of it, if you have something divided by s, try to think of it as f of s divided by s, and then you can find the corresponding inverse Laplace transform of f of s. This is f of tau, and then you integrate from 0 to t f of tau, then you find the Laplace inverse of f of s divided by s. Okay, now let us consider some examples here, so we can demonstrate the applicability of this result. Okay, so we have the following example here. Find the Laplace inverse of 1 over s multiplied by s squared plus omega squared. We need to find the Laplace inverse of this function. Now we can think of this one, 1 over s multiplied by s squared plus omega squared, as 1 over s squared plus omega squared divided by s. Okay, now what we have in here is, remember the formula f of s, we can think of it as f of s. Okay, f of s divided by s. Okay, so now we find f of t, or f of tau, the inverse, the corresponding inverse of f of t. Then the Laplace transform of f of s divided by s is the integral from 0 to tau, from 0 to t f of tau d tau. Okay, so find inverse Laplace transform of f of s the inverse Laplace transform of 1 over s squared plus omega squared. Okay, what is the inverse of this function? What do you think? S squared plus omega
Cosine,
squared.
Doctor.
Cosine if you have s divided by s squared plus omega squared, okay? But whenever we have a constant here, we can do the following. We can have 1 over omega multiplied by the Laplace transform, okay, the Laplace transform, or the Laplace inverse of omega. I change nothing. I multiply by omega and divide by omega. S squared plus omega squared. And this is the Laplace inverse of omega divided by s squared plus omega squared. This is nothing but sine omega t. So finally, what do we have is sine omega t divided by omega. Okay, so this is simply f of t. Okay, you can use f of t here, or you can have it f of tau. You can just focus on f of tau. Now this is f of t. So f of t is equal to sine omega t divided by omega. Now it turns out to know f of tau. What is f of tau? Because I need to evaluate the integral. What is f of tau? F of tau is sine omega tau divided by omega, right? Now I need the Laplace inverse of this one divided by s. So it turns out from here that the inverse Laplace transform of 1 over s squared plus omega squared multiplied by s, okay, is equal to the integral from 0 to t f of tau d tau sine omega tau divided by omega d tau. Okay, so in this case, what is the integral of sine omega tau? So here we have cosine omega tau divided by omega squared, okay, t and 0. Okay, in this case, this should give you, or simply minus cosine omega tau. So minus cosine will give you omega sine omega tau. Okay, so you can take the negative sign out. So here we have cosine omega t minus 1 cosine of 0 is equal to 1 divided by omega squared, or simply 1 minus cosine omega t divided by omega squared. Okay, so this is the inverse Laplace transform of 1 divided by s squared plus omega squared. Okay, is this clear يا جماعة? Any questions so far? Is it clear ولا لا؟
واضح دكتور واضح.
Okay, now let us consider one more example here. Find the inverse Laplace transform of 1 over s squared multiplied by s squared plus omega squared. What do you think? How do you find this one? What do you think يا جماعة؟
دكتور بنحط اس اوفر اوميجا سكوير بلس اس سكوير على اس سكوير، يعني عفوا اس شو اسمه تكعيب مش تربيع.
We do it like this: omega squared plus s squared multiplied by s, okay, divided by s. We know the Laplace inverse transform of this one. Tamam? Because we just obtained it. Hey, from here, we know it. 1 minus cosine omega t divided by omega squared. Okay, so this one is my now f of s. Okay, now what is f of t? F of t is the Laplace inverse of 1 over omega squared plus s squared multiplied by s. Okay, we just obtained that. So this one is equal to 1 minus cosine omega t divided by omega squared. Or you can start from here. You can start from 1 over omega squared plus s squared, and here you have to integrate twice, okay? But why do we need to do that? As long as we know the inverse Laplace transform of this one, okay? Okay, so this is f of t, so simply f of tau is equal to 1 minus cosine omega tau divided by omega squared, okay? And then the Laplace inverse, or the inverse Laplace transform of 1 over s squared plus omega squared, okay, is equal to integral from 0 to t, f of tau d tau, 1 minus cosine omega tau divided by omega squared d tau. Okay, and what is the integral of this one? So here we have t divided by omega squared minus sine omega t, sine omega, here we can have, okay, and step by step. Now we can have tau and then 0, okay, but the bottom line is that when you evaluate 0, okay, خلينا نحلها. Okay, so here we have tau minus sine omega tau divided by omega to the power 3, t and 0. So basically all what we have is at 0, tau should give you 0 and sine omega tau should give you 0. So here we have t divided by omega squared minus sine omega t divided by omega to the power 3. Okay, and this is the inverse Laplace transform, or the Laplace transform inverse, what do you want to say? Okay, of 1 over s squared multiplied by s squared plus omega squared. Okay, okay, any questions so far? Any questions? Do you have any questions? Okay. All right, 1 second. So here we have. Can you solve this one using a? Can you find the inverse using an alternative approach? What do you think? The inverse Laplace transform of 1 s squared multiplied by s squared plus omega squared. What we have in here. Can you think of partial fraction decomposition in this case? So now remember that 1 over s squared. So here we have another approach or another method. 1 over s squared multiplied by s squared plus omega squared. Okay. Have you heard about partial fraction decomposition? I think calculus 2 or calculus 3, right? سمعتوا في partial fraction ولا لا؟
بنعرف دكتور.
Okay, so this one can be expressed as 1 over s squared, okay, minus 1 over s squared plus omega squared. So if you simplify this one, so here you have s squared plus omega squared minus s squared, okay, so let me divide by 1 over omega squared, okay, or multiplied by 1 over omega squared. So after simplifying this, here we have s squared plus omega squared minus s squared. So what's left in the numerator is omega squared. When you divide it by omega squared, then you end up with having 1 in here, s squared multiplied by s squared plus omega squared. So in this case, what do we have? 1 over s omega squared multiplied by 1 over s squared minus 1 over omega squared multiplied by 1 s squared plus omega squared. So the Laplace inverse of this one, the Laplace inverse of 1 of s squared plus s squared omega squared is equal to the following, okay? 1 over omega squared multiplied by the Laplace inverse of 1 over s squared, okay? Minus, let me multiply this by omega and have omega to the power 3 here. So here we can have 1 over omega to the power 3, Laplace inverse of omega divided by s squared plus omega squared, okay? In this case, what is the Laplace inverse of 1 over s squared? T over omega squared minus, what is the Laplace inverse of omega divided by s squared plus omega squared? Sine. When you have s, you have cosine. When you have a constant, you have omega, literally. You have sine, okay? Sine omega t divided by omega to the power 3, okay? Which is the same answer obtained earlier using the integration property. Okay? Which one is simpler though? This one or this one? What do you think?
That then.
Okay, but you have to utilize the partial fraction decomposition approach. You will need partial fraction. Please go back and revise partial fraction decomposition from calculus 2 or calculus 3 because we are going to use it while we solve differential equations, okay? Differential equations using the Laplace transforms, okay? So basically the partial fraction decomposition is an amazing tool in order to find the inverse of the Laplace transform, okay? Okay, now let's move and talk about differential equations. So here basically we have differential equations initial value problem. Okay, now let us consider the following second order non-homogeneous differential equation. Consider y double prime, consider the ODE, y double prime plus a times y prime plus b times y is equal to r of t. So instead of r of x here, we will have r of t, just to be consistent with the definition of the Laplace transform, the integral from 0 to t or 0 to infinity e to the power minus st f of t. Now, if you want to keep it r of x, okay, as we learned earlier, okay, you can have another definition for the Laplace transform. So the Laplace transform becomes integral from 0 to infinity e to the power minus sx f of x dx, okay? But it should be the same. Tx is just a dummy variable, okay? Either you can have a function of x, y of x, or y of t, okay? It's the same. So now let's focus on r of t, just to be consistent. So here, instead of y of x, we will have y of t, just to be consistent with the definition of the Laplace transform. And we are given the following here. So we have y of 0 is equal to k0. Okay, and here we have y prime of 0 is equal to k1, okay, sub-constants. Now we want to solve such a differential equation. Of course, we want to take the Laplace transform of both sides. So now doing so, what is the Laplace transform of y double prime? What do you think? In the left-hand side here. So we start from here. What is the Laplace transform of y double prime? So here we can have the Laplace transform of y double prime plus a times y prime plus b times y is equal to the Laplace transform of r of t. Of course, this one comes out by the uniqueness of the Laplace transform. Since two functions are equal, then their Laplace transform are equal to, okay? Now, what is the Laplace transform of y double prime? You can apply linearity property here. Okay, I'm asking you, what is the Laplace transform of y double prime? So this one can be expressed as the Laplace transform of y double prime plus a multiplied by the Laplace transform of y prime plus b multiplied by the Laplace transform of y, okay? Should be equal to the Laplace transform of r of t, okay, or simply r. By the linearity, this is by the uniqueness of the Laplace transform, and this one by the linearity of the Laplace transform. What is the Laplace transform of y double prime? Who can tell me?
عادي أحكي.
Go ahead.
اللي هي اس تربيع بعدين مضروبة في اللابلاس ترانسفورم للواي تي
y of s, okay, for simplicity, or حتى we can use y in here, s squared y, okay. For one time I will write it y of s squared y of s minus
sy0 minus y prime 0.
Okay, plus, so here we have a. What is the Laplace transform of y prime? ندى اللي بتحكي صح؟
أكمل؟
Go ahead يا ندى. Yeah.
تمام، اللي هي حتكون اس مضروبة في اللابلاس ترانسفورم لواي تي اللي هي حنحولها هذا واي الاس minus واي 0
plus b كملي y of s is equal to r of s, where r of s is the Laplace transform of r of t, okay? Now look at these here, okay? So here we have the coefficients of y of s, here we have s squared, and here we have as, okay, and here we have b, so we can combine them. We have s squared plus as plus b multiplied by y of s, okay, minus sy of 0 okay, minus s minus a. Okay, so here we have y of 0, y of 0. We can have the following: minus s plus a, y of 0, minus y prime of 0 is equal to r of s. Okay. Now simply here, what do we have is the following. So y of s is equal to, we can move this one to the right hand side. So here we have s plus a, y of 0 plus y prime of 0 plus r of s. Okay, now we divide by s squared plus ax plus b. So here we have divided by s squared plus as plus b. Of course, I need to split this one, okay? So let me just split it, okay? We can have it basically one ratio like this, but I need to split this one. Okay, so here we have plus rs divided by s squared plus as plus b. Okay, now finally, if we define q of s as 1 over s squared plus as plus b. Okay, this one is q of s. Now we usually call q of s basically the transfer function. I will tell you why this one is called the transfer function. Okay, transfer function. Okay, all right. So now we can write y of s as we can see in here. So this is y of s. It's q of s. This 1 over s squared plus as plus b is a q of s. So it's s plus a, y of 0, okay, plus y prime of 0 multiplied by q of s plus rs multiplied by q of s. Okay, do you agree with me? Now, how do we find y of t, or the inverse Laplace transform of y of s? So y of t is simply the inverse Laplace transform of y of s. Okay, and it turns out that the Laplace transform or the inverse Laplace transform approach here is very powerful. So we can have the general solution. Okay, so remember, this one is a non-homogeneous second order linear differential equation. So solving such an equation in time domain requires that we start from the homogeneous solution and then we look for the particular solution for a given r of t. Okay, and now the general solution is the homogeneous solution plus the particular solution. Now in Laplace transform approach, okay, everything will be taken care of. So once you find the inverse, you will find the general solution, the homogeneous plus the particular. You don't need to split the problem into two problems, finding the homogeneous solution first and then finding the particular solution and then combine the particular and the homogeneous solutions together in one solution. Okay, so the inverse gives you a direct result, gives you directly the general solution of the problem. Okay. Now, let us focus on a special case when y of 0 is equal to y prime of 0. Now, if y of 0 is equal to y prime of 0, okay, is equal to 0, then it turns out that y of s is equal to, this one becomes 0, right, in here. This one becomes 0. So we end up with having r of s multiplied by q of s, okay? And from here, we can infer that a q of s is equal to y of s divided by r of s, okay? And that's why we call it a transfer function. Basically, it relates the input function with the output function. So here we have, this is the output, y of t is the output, and this is the input forcing function, okay, corresponding to an input. Remember, if we have a circuit plus minus, this is my r of t, okay, the input signal, and I'm interested in obtaining the output, solving the output current, for example, or the output voltage in here. So y of t should be the output, and r of t is the input. So q of s, the transfer function, is the ratio of the Laplace transform, okay, of the output signal or the output function to the input function, okay? And now this one, it turns out to be, this one is equal to 1 over s squared plus as plus b. And we can observe the function is not a function of the input signal r of t or the input the forcing function R of t. So it only depends on basically the coefficients of the differential equation. Okay, that's it. And the transfer function also is not a function of the initial conditions. Okay, it does not depend on the initial conditions y of 0 and y prime of 0. Okay, and again, as I said, it does not depend on the input function R of s. Okay, just the ratio between y of s and R of s is equal to 1 over s squared plus ax plus b. Okay. Now let us utilize this approach now in order to find the solution, okay, of differential equations. Now we will start with the following example. Okay, so here we have, and let's see how quick and easy is to use the differential, to use the Laplace, the inverse Laplace transform to solve differential equations. So here we have y prime minus y is equal to t. We are given that y of 0 is equal to y prime of 0, and this one is equal to 1. Okay. Now we want to find, of course, we want to find the Laplace transform of both sides. Okay. Who can tell me what is the Laplace transform of the left-hand side? يلا يا جماعة. يزن.
دكتور معك بس والله يعني تقريبا هسه صحصحت يعني كنت والله سهران.
سارة درويش. Okay. يلا give me the what is the Laplace transform of the left hand side?
هلا خطوة بخطوة.
Yes.
اوكي هلا s squared y of 0
S squared y of 0
minus
S squared y of 0
y of s
S squared y of, okay,
minus s y of 0
S squared y of s. Okay, we can have y only, okay, for simplicity. Okay, so here s squared minus y minus s y of 0 minus y prime of 0. What is the Laplace transform of y? Is simply y, okay? What is the Laplace transform of t?
1 over s تربيع
1 over s squared, right? So we know that y of 0 is equal to y prime of 0, which is 1, okay? So finally we have s squared y minus y, okay, minus s minus 1 is equal to 1 over s squared, okay? And here we have s squared minus 1 times y is equal to s plus 1 plus 1 over s squared, okay? So y of s finally is equal to s plus 1 divided by s squared minus 1 plus 1 over s squared minus 1, okay? That's it. Now you can simplify this further. So here you can have s minus plus 1 divided by s minus 1. So here we can have 1, you can simplify it 1 over s minus 1, okay? After dividing the top and the bottom of this ratio by s plus 1, okay? Now what about this one? So we need to find the inverse Laplace transform, okay? So what about this one? So here we can use the partial fraction decomposition approach, okay? So this one can be expressed as 1 over s squared minus 1 over s squared minus 1. So it turns out that what we have is the following. Oh, sorry, here we have minus and here we have plus, okay? So here we have minus s squared plus 1 plus s squared divided by the product, okay? Of course, here you need to apply the partial fraction decomposition. So the partial fraction decomposition of this one is s squared minus 1. Okay, let me abuse the notation here. So خلينا نحكي هون we have u and u minus 1. S squared is equal to u, okay? So 1 over u minus 1. So this is a simplified approach to have basically the partial fraction decomposition. Other than that, you need to have the following. يعني you can think of it because you have s squared and s squared. You have to think of it from this perspective, u and u minus 1. So here you have a u plus a divided by u minus 1. Sorry, a1, and here we have a2. Okay, so it turns out that this one is equal to 1 over u minus 1. Now here we have a1 u minus 1 plus a2 times u. Okay, this one should be equal to 1. Okay, so if u is equal to 1, then a2 is equal to 1. Okay, so this is a2. Okay, this one, a2 is equal to plus 1. Now, if u is equal to 0, then a1 is equal to minus 1. So this is minus 1. So a1 is equal to minus 1. By the way, this is not generally true if you have s here. If you have s squared minus 1, then you have to do the partial fraction as we can see. So here we have, remember, s minus 1 is squared minus 1. This one, a على s plus a divided by s minus 1, a2, a1 plus a3 divided by s plus 1. Okay, this is not the case also when we have s squared times s minus 1. So here we have a over s plus b over s squared plus c s minus 1, okay, or a1, a2, a3, okay? But this one is a special case. When we have s squared, we can realize it as u multiplied by u minus 1 and perform the partial fraction decomposition with respect to u, and then we can go back and substitute u equals s squared, okay? Anyway, this is not my job to teach you partial fraction decomposition. I will assume that you know how to perform partial fraction decomposition for anything. Please go back and revisit this in calculus, okay, and revise it very efficiently and very quickly. So we need it in this course. We need to find the inverse Laplace transform when we solve differential equations, and most of differential equations we need to solve will require partial fraction decomposition. Okay, so it's your basically job to go back and revise a partial fraction decomposition. Okay, so I will eliminate this one so you don't get confused. Okay, now we find y of s. Okay, so it turns out that from here that this is my y of s. Now we need to find y of t in this case. So this is the inverse Laplace transform of y of s. Now by the linearity property, so here we have the inverse Laplace transform of 1 divided by s minus 1 plus the inverse Laplace transform of minus 1 over s squared plus the inverse Laplace transform of 1 s squared minus 1. Okay. Now what is the inverse Laplace transform of 1 over s minus 1? This term, the first term. What do you think? Farah, what is the inverse Laplace transform of 1 divided by s minus 1?
مش عارف صراحة.
e to the power t. e to the power at, 1 divided by s minus a. Okay, so a is equal to 1. So 1 e to the power at has a Laplace transform of 1 divided by s minus 1. Okay, what is the Laplace transform of minus 1 over s squared? One over s squared. T
minus
t, if you have f of t is equal to t, then this has a Laplace transform of 1 over s squared. So 1 over s squared has an inverse Laplace transform of t, but since we have minus sign, so here we have minus t. Okay, what is the inverse Laplace of this one? Sin t. لو كانت بلس بتصير ساين. Okay, so this is sin t. Remember, 1 over s squared minus a squared is the Laplace transform of sin a t. Okay. All right. So this is e to the power t minus t plus sin t. This is y of t. Okay. We obtained y of t. It's very simple. So all what you have to do is to find y of s from this equation. Okay. Now, you need to deal with partial differential equations in order to write y of s in pleasant form, so you can find the inverse y of t easily. Okay, that's it. Now let's solve the equation in here in time domain, and let's see if we get the same answer. So remember, in time domain we have y double prime minus y is equal to t. Okay, we have y of 0 is equal to y prime of 0, and this one is equal to 1. So from here we need to find y homogeneous. Okay, so the auxiliary equation lambda square minus 1 is equal to 0, so lambda is equal to plus and minus 1. So finally the homogeneous solution is c1 e to the power t plus c2 e to the power minus t. Okay, now the particular solution yp, we can choose yp as a times t, so yp double prime should be 0 minus a is equal to simply sorry, here we have y, I'm sorry, okay, minus at is equal to t. Then it turns out that a is equal to minus 1 and yp is equal to minus t. Then the general solution is y homogeneous plus y particular. Okay, and in this case we have c1 e to the power t plus c2 e to the power minus t plus or minus minus t. Okay, now y of 0 is equal to c1 plus c2 minus 0 is equal to 1. So it turns out that c1 plus c2 is equal to 1. Okay, y prime of 0, okay, after you take in the derivative, so we end up with having c1 here, and here minus c2 minus 1. So here we have c1 minus c2 minus 1 is equal to 1. So c1 minus c2 is equal to 2. Now it turns out that c1 is equal to 3 over 2 and c2 is equal to minus 1 over 2. So finally the general solution y of t is equal to 3 over 2 e to the power t minus 1 over 2 e to the power minus t minus t. Okay, so how do we get the sinh t in here? Okay, how do we simplify this one? Okay, such that we have sinh t. What do you think? What do we have to do in here? We can write 3 over 2 e to the power t as e to the power t plus 1 over 2 e to the power t minus 1 over 2 e to the power minus t minus t. What is this in here? Sinh t. Okay, so finally what do we get is e to the power t plus sinh t minus t, which is the same result obtained using the inverse Laplace transform. Okay, but here we don't need to find the homogeneous solution and then the particular solution. Then we need to find to solve a system, a linear system of equations, two equations with two unknowns, to find the coefficients and so on. Okay, so we can use the Laplace transform or the inverse Laplace transform approach to solve such a differential equation. Clear, يا جماعة? Any questions so far?
دكتور والله
Okay.
بس سؤال،
Go ahead.
باللي فوق دي بقدر افككها لاربع اجزاء زي ما انت حكيت يعني؟
Yes, you can, but it will take a lot of time finding A, B, C, D. Okay?
دكتور بس يعني قصدي انه لو فككناها راح تطلع من نفس جواب البارتيكولر والهوموجينيوس مع بعض.
What do you think? What do you think from the uniqueness of the Laplace transform? What do you think? It's a must. لازم.
صحيح. لا بس قصدي يعني اذا مثلا ما كان ناسي واحد مثلا لابلاس ترانسفورم للسينش مثلا، فبيضطر يفككها اكثر عشان يعرف مثلا يعني اجزاء اكثر.
Yeah, it will be يعني it will be reduced to this form finally. Okay, you can try it. You can try it and let me know what you get. Okay.
تمام.
Okay. All right. So here we have the following example. Okay. Y double prime plus y prime plus 9y is equal to 0. We know that y of 0 is equal to 0.16. Okay, so and here we have y prime of 0 is equal to 0. Now this is very simple. We need to take the Laplace transform of both sides. So here we have s squared y plus, minus y of 0 minus y of 0, which is 0.16 y of 0 times s 0.16, okay, s minus y prime of 0 is 0, okay, plus y prime s y minus y of 0.16, okay, plus 9y is equal to 0. Okay, now let us see here we have y, so s squared, okay, plus s plus 9 times y, okay, is equal to, or we can say minus 0.16 s plus 1, okay, is equal to 0. All right, or simply we can always solve for y, so y is equal to 0.16 multiplied by s plus 1 divided by s squared plus s plus 9. Okay, so this is y of s simply. Now we need to find y of t, which is the inverse Laplace transform of y of s. Okay, how do we proceed? مين بيقدر يحكي لي؟ How do we find y of t? What do we have to do here? Now, if you have something like this, s squared plus s plus 9, always think of completing the square, okay? So this one can be expressed as, okay, let's forget about the numerator first, okay? Now, the denominator can be expressed as s plus, so here we have s squared plus s plus 9. So we can have s plus 1/2 squared. This one should give you s squared plus s plus 1/4. So what's left is 9 minus 1/4, which is 35/4. Okay? Do you agree with me so far? So we can complete the square. So think of it as s plus 1/2 squared plus 3/5, okay, over 4. Okay, or you can have, you can write it that way. Okay, عشان بس this one will be corresponding to omega squared, okay? So here we have squared plus squared, okay? Now here we want to write the numerator as something s plus 1/2, and then you can take the advantage of the inverse of sine and cosine. So here we can write 0.16 multiplied by s plus 1/2 plus 0.08. Okay, just we need to have s plus 1/2 in here and in here, in the numerator and in the denominator. Okay, now finally you can basically write the following. So this one should be equal to, okay, and I want to write it like this from here. So this one is equal to 0.16 multiplied by s plus 1/2 divided by s plus 1/2, okay, squared plus square root of 35 divided by 4 squared, okay, plus we have another term in here, we can have it like this, 0.08 divided by s plus 1/2 squared plus square root of 3/5/4 over all squared. So here we just have to write plus, okay? Now, this is y of s, okay? Now, you can easily find y of t by obtaining the inverse, okay? What is the inverse of this one? Let me ask you, what is the inverse of this one? So this one is being written in the form s minus a divided by s minus a squared plus omega squared, okay? And the Laplace inverse of this one is equal to e to the power at cosine omega t. That's it. So from here we infer that this one has a Laplace inverse. Okay, يعني هون we can write y of t. Okay, let me write it one more time. So here we have y of t is the Laplace inverse of 0.16, okay, s plus 1/2 divided by s plus 1/2 squared plus square root of 3 5 over 4, okay, squared, okay, plus the Laplace inverse of 0.08 divided by s plus 1 over 2 squared plus square root of 3 5 4 squared. Okay, now it turns out that what is the Laplace inverse of this one? Here we have 1.6, we can take it out, okay? So s plus 1 over 2, so basically we have e to the power minus t over 2, okay? Multiplied s divided by s squared, because of the shift, s divided by s squared plus omega squared. So here we have cosine omega t, okay? And in this case, omega is equal to square root of 35 divided by 4 t. Do you agree with me so far يا جماعة؟ هاي لحالها cosine omega t has a Laplace transform of s divided by s squared plus omega squared. But since we have s plus 1/2, then this implies that we multiply this function. Remember, when we shift the s domain function by a units, then basically we multiply the time domain function by e to the power at. Okay, so the corresponding inverse is e to the power minus t over 2 multiplied by cosine square root of 35 divided by 4t. Okay, now what about this one? What is the inverse of this one? What do you think? يلا مين يحكي لي؟ ما سمعتك.
يقول ممكن يعني قريب على الساين هي.
Okay, what do you need to do in order to convert it to sine? Remember, sine, when we have sine here, the Laplace inverse of omega divided by s minus a plus omega squared, this one is e to the power at multiplied by sine omega t. So let us multiply by omega and divide by, multiply this term by omega and divide by omega, okay? So here we can multiply this one. يعني ممكن نحكي هيك 0.08 divided by square root of 35 over 4 multiplied by the inverse Laplace transform of square root of 35 divided by 4 divided by s plus 1 over 2 squared plus square root of 35 divided by 4 squared. Okay? Now this one is in the form omega divided by s minus omega squared plus omega squared. So it has an inverse Laplace transform of sine omega t. So, and finally, what do we have is 1.16 e to the power minus t over 2 cosine square root of 35 divided by 4 multiplied by t plus, here we have 0.16 because we have 35 divided by 4, so 2 in here, so we can take 2 in the numerator here, so 0.16 divided by square root of 35 multiplied by e to the power minus t over 2 because of the shift in here, multiplied by sine square root of 35 divided by 4t. Okay, so this is the inverse Laplace transform of the function y of s, and this is the solution of the differential equation. Okay, this is y of t. Okay, simply this is y of t. كلير يا جماعة ولا لا؟
كلير
سؤال.
Go ahead فرح.
دكتور فوق بالنيوميريتر لما حولناها 0.16 s plus half plus 0.08 ما فهمت كيف حولناها.
You mean this one?
لا انه بالنيوميريتر لما عملناها انه in terms of s plus half.
عن اي وحده بتحكي عن هاي؟
هاي بس انه الفوق شوي لما حولنا
Okay, let me stop recording because we just finished, okay?